Welcome everyone to the channel, and this is the new video of our binary tree series. And here we're gonna solve the question 1305, which names all element in a two binary search trees. So first of all, we need to understand that what is a binary search tree. So practically, if we see, uh, there's a your root present in the tree, and if a root left not equals to null, then we have also a root right present, and the root left also present. So here we see, if our root left means root have a specific values, root value is greater than root left value, then we can say that binary search is working. And then the second step, if the root right value is bigger than the root value, then it's a complete process of the searching a binary tree series. Means you have a first you have a root left value, then after root, and then after root right value. Means the root right values are the one of the best, we can say that one of the largest value of the trees. Let's suppose here is the 2, sorry, here's 3, and here's the 4, and here's 5. Okay, so 4 is a root value, so root value is bigger than the root left value, and then root right value is bigger than the root value. So this is the process for identifying whether the tree is a binary search tree or not. And here we see the question. We given our two binary trees, root 1 and root 2. Return a list containing all integers from both trees sorted in a ascending order. Let me check the phase. So yes, it's good. Okay, so here we have a root 1 1 to 4 and root 2 103. So you see, 1 is smaller than 2, and 2 is smaller than 4. So here we go through this. They both are binary search trees. After that, we are gonna output 0 1 1 2 3 4. And in the second example, we see the root 1, which is a 1 null 8, and root 2 8 1. Okay, and we also have output 1 1 8 8. So what is the common between the example 1 output as well as the example 2 output? Yes, you think right. They both are in the sorted manner. So we need to apply a sort function, but at a last, what we do the first, to search element, we have a three orders, like a pre-order, in order, as well as a level transfer order, a level order traversal. Mainly three traversal, which is working on the binary trees. And we're gonna apply a pre-order to store this values, to search the elements in the trees. So first of all, after applying a pre-order, we have to store all the element in the, like an answer name vector, and then we sort the both element of the answer. So first of all, we make a function named in order, and then we call in order to recursively to store the values of the each trees. That means both the trees. So in order, okay, and then we have to do this. After this tree node, right here, okay, tree node, we store the root, and after that we apply the vector, which is of integer data type, and it stores name pack. Okay, after all that, just do this and apply the base condition. If our root is equals to null, then we have return back. Okay, and then we used in order root left, okay, into a vector. After that we apply semicolon, and again we push vector to push back root value, because in order we firstly store the root left values, then after root, and then after right. Okay, and this is also a binary search, also works on this principle, in the principle of in order. We firstly store the left value, then after right, and then after, sorry, left value, then after root, and then after right. So this is the principle, and we just push back, okay, this into root value in the vector name, vector name variable, which is also named as a vec. Okay, and we apply in order. You can name anything as you want. Okay, in order root right comma vec okay, and apply a semicolon into this, and at last we another make a variable which is of n data type name as answer, where we store the value, okay. We apply recursively of in order function, sorry for the spelling mistake, and in order, okay. Here we apply a root one, which is the first tree, and then answer, in which we store all the values. Again we have in order, okay, sorry, in order, okay, root 2, and then answer, okay, and then again apply with semicolon, and at last we just talk about the sort function, that we need to apply a sort function for, you know, this kind of series 0 1 1 2 3 4. They both are in the sorted manner, all the numbers 1 1 8 8 also. If we apply an unordered set, then what happens? Please comment out. In an unordered set, we don't need you know, any repeated numbers in the vector. Like if this is a 0 1 1 2 3 4, then we got the 0 1 2 3 4. One is popped back into the vector, okay. Okay, we apply a sort function, and answer dot begin, okay, and then answer dot end, okay, and the semicolon, and we return the answer, okay. And this is the code for this question. Now we run it and see what happened. Yes, the both the test cases are the accepted, and we just need to submit this, okay. And hope it runs. Yes, the code run successfully. And this is for today, guys. We meet in the next video.